All right, back with question 5, the practice final. What we have is we have a almost a copy and paste of question 2. Um, so let's jump right in. Part A. Part A. We want to find big H sub 1 of e to the j omega, which is equal to the Fourier transform of 1 over 2 to the n times u of n. And this is pretty simple. It's right off the table. You have 1 over 1 minus 1 half e to the negative j omega. So that's that. It's handy to remember the Fourier transform of something like this, of a simple one like that, because it's if you take 304, this is it's gonna be popping up a lot. Now b h sub 2 of e to j omega is equal to the Fourier transform of h1, or excuse me, little h sub 2 of n, and that's sinusoid, and this is the same as it was in continuous time, so it's pi over j delta of omega minus 0.3 pi minus delta of omega plus 0.3 pi. This is a handy one to remember too, as well as the cosine. The cosine and the sine are extremely similar, and it makes a lot of sense too, because if the Fourier transform is telling us what's the frequency content of our signal, well, um, you know, it only has one frequency. It's right there. So, and then it's going to ask us what is h of e, or h big H of e of j omega, where h big H is corresponds to h sub n, or excuse me, little h of n. And little h of n is the series connection of h1 and h2. So h of n is equal to h1 of n convolved with h2 of n. And in the frequency domain, that tells us that big H of e to the j omega is equal to big H sub 1 of e to the j omega times big H sub 2 of e to the j omega. And when we do that, we are going to get, we'll have, let's take the pi over j and put it right up front right now, and then we'll distribute the delta function. So we'll have delta of omega minus 0.3 pi all over 1 minus 1 half e to the negative j omega, and then minus delta of omega plus 0.3 pi, and this is all over 1 minus 1 half e to the negative j omega. And just like we did in, I think it was problem 2 or problem 3, something like that, we're going to apply the sampling property, and this delta function is 0 everywhere except at 0.3 pi, right? So if this is only 1 at 0.3 pi, then we can change out this j omega here for the omega for 0.3 pi. So we get pi over j delta of omega minus 0.3 pi all over 1 minus 1 half e to the negative j 0.3 pi minus delta of, now for this one here, we have omega plus 0.3 pi. We want it to equal 0. So that tells us that omega is equal to negative 0.3 pi. So we have delta of omega plus 0.3 pi. And that's over 1 minus 1 half e to the, would be negative j times negative 0.3 pi, or we can just write j to the 0.3 pi. And that is Yeah, that's this one. And like I said, that one was pretty simple. So it's a copy and paste of the previous one, just in DT. I'll be back with another video soon. Thanks.